Now let us see an arrangement of three charges where they are not in a straight line. Here the three charges form a right-angled triangle. The magnitude of the three charges and the distances between Q1 and Q2 and between Q2 and Q3 remain the same as before. Let us now see what happens to the force on Q2 in this arrangement. As usual, we draw the free body diagrams first. We take the right direction and the upwards direction as positive, and the left direction and the downwards direction as negative. The force on Q2 due to Q1, written as F12, will be upwards, as they are opposite charges and attract each other. Therefore, Q1 pulls Q2 upwards. The force on Q2 due to Q3, written as F32, will be towards the right, as opposite charges attract, and therefore Q3 pulls Q2 towards the right. The magnitudes of the two forces acting on Q2 remain the same as before. You can verify these results. We can see that the resultant force acts somewhere between the direction of F12 and F32. Since these two forces are acting along perpendicular directions, we can add the two vectors easily. Using the tail-to-head method that we learnt in Chapter 2, we place the tail of vector F12 on the head of vector F32. We then join the tail of F32, the origin, to the head of F12. This gives the resultant vector Fnet. We can use Pythagoras' theorem to find the magnitude of this net force acting on Q2. Fnet squared equals F12 squared plus F32 squared Fnet equals 4,14 times 10 to the power -8 Newton. The direction of Fnet, given by the angle made by Fnet to the positive x-axis, can be found using the tangent trigonometric ratio. Tan theta equals y component of force over x component of force equals F12 over F32, which equals 0,21. Therefore, theta equals tan inverse 0,21 equals 11,86 degrees.
Fnet is at an angle of 11,86 degrees in the anticlockwise direction from the positive x-axis.
Starting to feel it? Now go master it with maskitv.